So today I'm going to do a tier list on transportation systems for space logistics. So it's a ranked tier list. I'm going to go over a number of different systems for moving things around in space, getting things to space, and then moving them around in space. So let's get into it. Here it is. Here's the tier list. And I'll put myself in the corner. So let's start with good old chemical thruster. This is how we move things around in space at the moment. These systems are very mature, reliable. They're used for launching mass into orbit from Earth and also for moving things around in orbit. For practical purposes, chemical thrusters are the only way of getting mass from the surface of Earth to space. Once in space, there's more options, but practically at the moment, chemical thrusters is what is used. There are some systems in this tier list that are potentially alternatives, but chemical thrusters is the main way. Chemical thrusters have high thrust, but they have low fuel efficiency. If you want to transport humans from, say, low Earth orbit to the Moon or Mars, you'll probably want to use a chemical thruster because of the high thrust. You want to get to your destination quickly. This only really works for the Moon and potentially Mars, but no further because of their poor fuel efficiency. A future alternative to chemical engines for launching mass from Earth into space, at least for consumables or propellants or simple payloads, would be electromagnetic rail systems. So this is typically a cradle. You put your payload into the cradle, and the cradle is accelerated to very high speed, Mach 5 or Mach 6, and then it flies off into space. So this is fine for consumables, propellants, but probably not for complicated satellite platforms, and certainly not for humans or anything like that. But it does have potential uses. So I'm going to put fusion drive at the S tier, as a nuclear fusion drive would open up the entire solar system for cargo and payloads. Fusion drives are not for human transportation because they are low thrust, and it would take too long for humans to move around using this system. Every day, humans need to be provided with food and water, and also they're exposed to radiation, and the microgravity is not good for human health. So you want to use something that has very high thrust, and fusion drives, at least at the moment, are low thrust. They're extremely high efficiency. The amount of energy you get from a fusion drive versus a chemical thruster per unit of mass is 10 million times more energy than a chemical thruster. So the fuel efficiency is extremely high. Just 10 grams will get you to Mars, and 100 grams can get you to Pluto. So fantastic efficiency, and you can move large payloads around the solar system. You can support and sustain a human habitat on the Moon or Mars using a fusion drive, but they're not suitable for moving humans around. So this is a pulsed arc thruster, and I've covered a number of companies working on this. There's Newman Drive from Australia, and there's Mag Drive from the UK. And this is used on a metal propellant rod. You zap the rod with electricity, and it turns a small amount of the metal into plasma, which is then ejected from the end of the pipe and generates thrust. And you can propel the vehicle forward using that. There's a lot of scrap metal in orbit already, so if you were to collect that, forge it into metal pipes, you could power spacecraft using a pulsed arc thruster. So potentially that's an excellent way for moving payloads and cargo in low Earth orbit and throughout cislunar space, and maybe even to Mars. Gas gun, I've covered Longshot, which is a startup that's working on guns that can shoot payloads into space, and it uses compressed gas. A payload is sent through a pipe, gas is released to accelerate it, and if you get the timing right, you can keep accelerating the payload until it leaves the tube at Mach 5. Similar to the electromagnetic launch rail. You can quickly get Mach 5, and then again you'd use a booster to reach orbital speed. So a nuclear electric propulsion system uses a nuclear reactor to generate electricity, which then powers an electric propulsion system. So that would be a series of ion thrusters powered by the nuclear reactor. These systems are very good for cargo. They also are very good for robotic probes because they generate a lot of onboard electricity. So once you've reached orbit around Mars or some other planet, you don't need the electricity for propulsion. It can then be used for the payloads to power very advanced equipment and potentially a lot of AI computing or whatever you need it for. Potentially hundreds of kilowatts or even megawatts of electricity would be available. So nuclear electric propulsion is an excellent way of moving cargo, and also it's very good for robotic probes. So a radioactive cell, I've covered this concept already on my channel. The concept is called T-thinner, and it's a NASA proposal to use a radioactive sheet. One side is insulated so you get asymmetric thrust, and that asymmetric thrust moves the sheet in one direction only. Because radioactive materials expel particles at very high speed, perhaps 5 or more percent the speed of light, you can get very high fuel efficiency and you can generate very high speeds over time. And it's a sail, so you use rigging to steer. And your payload would be suspended behind the radioactive sail. So this is not suitable for humans or anything like that. But you could move cargo around the solar system and you could get very high speeds eventually. Solar thermal propulsion. I've covered a company working on this type of propulsion, and that company is Portal Space Systems. And this system uses the heat from the sun, which is concentrated and then directed onto a heat exchanger, and the propellant is inside there. It's heated and turned into a plasma, which is then ejected from the end of the rocket through a nozzle, and that can generate thrust. So this doesn't use combustion, it simply uses a single propellant, and it uses the heating of that propellant to generate thrust. So there's no chemical reaction. You could top up the propellant and get more delta V. So the ideal fuel would be hydrogen, but because it's quite difficult to work with, Portal Space Systems will probably use ammonia, which is NH3. So it's mostly hydrogen once it's disassociated and turned into a plasma. Also, you could potentially use water as well, which is H2O. But eventually you'd want to use hydrogen. It's the lightest element, and therefore you get the highest exit velocity, which means it's the most fuel efficient. And this is the bridging technology to the next propulsion system, which is NTP, or nuclear thermal propulsion. And the reason I put it in the S tier is it has high thrust. Other than chemical thrusters, there's no other system that has high thrust. So this makes it suitable for transporting humans around the solar system. But also it's very good for anything you want to move quickly from point A to point B. Nuclear thermal propulsion uses a nuclear reactor to heat a propellant, which is then ejected at high speed from the vehicle, and that generates thrust. And the thrust can be very high. So this is one of the best systems to move humans from Earth to Mars, or even further. And solar thermal propulsion is a good bridging technology to nuclear thermal propulsion. All you need to do is replace the solar reflectors with a nuclear reactor, and the rest of the system would be the same. And we have electric propulsion, which is very common on satellites for station keeping. It has extremely low thrust, but it is very efficient. So for minor course corrections, such as station keeping, it works. You can also use it for orbital debris avoidance maneuvers. It only works well in that case if you have plenty of time. If you have to make a very quick maneuver, it may not be suitable because, again, it has very low thrust. You'll find most of the satellites in constellations will use some kind of electric propulsion, usually a Hall effect thruster. So you'll find them on Starlink satellites and many, many other satellites. And I put Space Elevator here. It's not really a transportation system. It does allow you to lift mass from the Earth into low Earth orbit, or potentially off the moon to low lunar orbit. This can't be done at the moment, but if you have a large moon base, you could build a space elevator. The materials needed for an elevator on the moon already exist. Kevlar or Zyblan has enough tensile strength to support a space elevator on the moon. Currently, there's nothing really that could be used for a space elevator on Earth. Perhaps carbon nanotubes, but they can't be made long enough at the moment. So this is really a science fiction piece of technology, at least for the Earth, for another 10 or 20 or 30 years. This is a quick rundown of some of the transportation systems for efficiently moving logistics, cargo in cislunar space to Mars, and further out to the outer planets. That is my opinion on the different systems that could be used for efficiently moving cargo around. For moving humans around, there's only two possible types of propulsion: chemical thrusters, which are used now, and in the future, nuclear thermal propulsion. Every other system is just too low thrust. For humans, you want to get to the destination as quickly as possible because you don't want to carry a huge amount of consumables and oxygen and water. And also you don't want to expose the crew to galactic cosmic radiation. So you want a high thrust system. But for cargo and resupply missions, low thrust is fine as long as it's fuel efficient. There's many alternative propulsion systems that could be used. And there's many space startups working on these alternative propulsion systems. So hopefully in the next 5 or 10 or 10 or 15 years, we'll see more of these systems actually in use and operational. So please leave your comments and thoughts below, and we'll discuss at the weekend live stream. Okay, thank you for watching, and I'll see you next time.